This video is on solving two-step equations. So the last video we covered one-step equations. So this time around we will be applying inverse operations 2 times. So in the last video when we did one-step equations we only had to apply the inverse operations once. So remember our goal when we're solving equations, we're trying to solve for this pronumeral here. So that means in our way is the 5, or really it's a positive 5 because there's no sign at the front. I know it's a positive 5, and also this minus 2, which is joined by to the d, the pronumeral, by a multiplication sign. And that joining is actually very important because it tells you which inverse operation to apply. So we're going to do this 2 different ways because I think it's important to see. You can see that you can solve an equation in more than one way. And the first thing we're going to do is we're going to move the 5 onto the other side. And we're going to apply inverse operations to the plus 5 by taking away 5. That's the inverse operation. And so 5 take away 5, I know that's 0, so I'll cross that out. And what I'm left with is minus 2d. There's the first place where students make errors, is they forget the minus sign. So please don't forget there's a minus sign in front of the 2d, in front of the 2d. And then on the right-hand side, 19 minus 5 is 14. So that's my first set of inverse operations. That means it's one step. Now let's do the second step. So we are going to now try and move the minus 2, and it is connected to the d by multiplication, so the inverse operation would be to divide. So the opposite of multiplying is to divide, and don't forget this is what I'm dividing by. So the opposite of multiplying by minus 2 is to divide by minus 2. Sometimes students will drop the minus here, but we are only reversing the operation, and the operation we're reversing is the multiplication, which is why I've got the division. Nothing else changes. So minus 2 divided by minus 2 is 1. I don't need to write 1d. If you want to write 1d, you can. I won't be writing 1d, but it's important for you to understand that when we do the inverse operation, the numbers don't disappear. We end up getting a 1. And on the right-hand side, 14 divided by minus 2 is minus 7. And that is my solution. Now, over here, the other way of doing this, solving this equation, is if you wanted to move this entire 2d term to the right-hand side, you could. And because it's one entire term, the opposite of taking away 2d is to add 2d. So I'd have to add 2d to both sides because whatever I do to one side, I must do to the other. And what I'm left with then on this side is 5 because minus 2d plus 2d will give me 0. And then on this side, I get 19 plus 2d. From here, you could then remove or move this positive 19 by subtracting 19 from both sides. And that gives me minus 14 on this side and then 2d because 19 minus 19 is 0. And then I could divide by 2. And that gives me d on the right-hand side, and on the left-hand side I get minus 7. But since the two sides are equal, you really can just reverse it. So you can write d equals minus 7 as your final answer. All right, next set of equations. So once again, two-step equations, and I could actually solve this equation in one step. So we actually did an equation just like this in the last video. So I want to solve it in one step, and then I will solve it in 2 steps. This equation reads 4/3 multiplied by some number called x is 16. And so the opposite of multiplying by 4/3 would be to divide by 4/3. Divide by 4/3. So whatever I do to one side, I do to the other. And hopefully you know that when I divide by 4/3, the 4/3 will give me 1 because any number divided by itself is 1. So this will turn into 1. You don't have to write 1x, but you can. Okay. And then on this side, I just need to go back to year 7 and do some fraction work. 16 divided by 4/3 is exactly the same as 16 multiplied by 3/4. So I'm doing a keep the first number the same, change the division sign to a times, and then flip the second fraction, which is really the reciprocal, and then I can multiply these. Hopefully you're good with cancelling because I can see that 4 goes into 16 4 times, and 4 3s are 12. So my solution is x equals 12. The other method I can use to solve this equation is I could remove the two numbers in 2 separate steps. So the first number is a 3 and then a 4. And what I want you to understand is that 3 traps the numerator. So I can't really touch the 4x until I remove the divide by 3. The opposite of dividing by 3 is to multiply by 3. So I'm going to do that on both sides, and this 3 in the numerator divided by the 3 in the denominator will cancel to give 1. So I'm just left with 4x, and on the right hand side, 16 times 3 is 48. And then I can remove this 4, well it's joined to the x by times, so I will divide by 4 on both sides, giving me x equals 12. So it doesn't matter how you proceed, you will get the same result if you use either method. Just understand there are more than one way to solve each of these equations. All right, next set of equations. This is as hard as it gets in the two-step equations. They look very similar. They look the same, but there's a difference here. This fraction bar extends all the way across underneath both the x and the positive 3, whereas in this question, the fraction bar is just underneath the x. So we're dividing the x by 5, whereas in this equation, we're dividing x plus 3 by 5. That actually makes a big difference with how to proceed with both of these equations. In the second equation, my 3 is free to move. It isn't trapped by this division sign. So when I divide by the x plus 3 by 5, it means all of this number, the whole x plus 3, whatever that number is getting divided by 5. Here, the 3 can be moved first. So in this equation, this plus 3, I'm going to apply inverse operations to the plus 3 first by subtracting 3. I am not able to subtract 3 with this equation until I remove the 5, because the 5 traps this x plus 3. So I actually proceed differently with both equations. So the minus 3 is free to move. So when I subtract 3 on this equation over here, I will get 0, leaving me just with x on 5. And on the right-hand side, I will get 7. And then I can apply inverse operations with the divide by 5, and I will multiply by 5. And then this 5 in the numerator divided by 5 in the denominator will give me 1. So I get 1x, and on the right-hand side, I get 35. In this equation over here, I cannot proceed the same way. I cannot subtract 3 because of this 5 that is in the way. So what I will do is I will use an inverse operation for divide by 5, and that is multiply by 5. So I'm going to multiply both sides by 5, and then that 5 in the numerator will cancel with the 5 in the denominator, and I will have x plus 3 equals 50, and then I can apply inverse operations with the plus 3 by subtracting 3, and this will give me 0, so I'm left with x equals 47. So because the equations aren't the same, I don't get the same solution. All right, let's recap what we've learnt. What I want you to do is look at each of these equations and decide what operation will I apply first. So I want you to pause the video and write down which part of the equation will you apply inverse operations to first, and then I want you to unpause and see if we agree with each other. All right, let's go. So in this equation, I can see that the divide by bar traps the p minus 3. So the very first thing I would do with this equation is I would multiply both sides by 5. In this equation, however, I can see the divide by 5 only traps the p here, so what I would do is I would take away 3 from both sides of this equation. With this equation over here, I can see that I've got the p, and I've got a minus 2 and a 3 to be moved, but the minus 2 is attached to the p, so I'm actually going to deal with that last. What I would do is I would subtract 3 from both sides before I even move on to dealing with this term here. Now, this one's an equation that we actually haven't looked at, and I wonder how many students will know what to do here. What I would do here is I wouldn't even apply inverse operations. I would actually collect like terms, because 13p and 2p are like terms. So I would actually collect like terms first, giving me 11p equals 10, and that would be the very first thing I would do with this equation. And then once I've got my 11p equals 10, hopefully you can tell me that the inverse operation of multiplying by 11 is to divide by 11. And so that would be what I would do first, giving me p equals 10 over